Good afternoon, everyone. Welcome to this breakout session on React. So my name is Yi Chen. I'm a professor of Business Analytics at the UC. So before I introduce our speaker today, let me make a few quick announcements. So they have generously agreed to allow us to record the presentation, so you'll be able to see the replay afterwards. And also, the students will hand out surveys during or before the presentation. So please consider to fill out the surveys. It really helps us to to make sure that what we are doing right, what we are doing wrong. Okay, so that's it. So now let's introduce our esteemed speaker, Dave Ramsey. Dave Ramsey is the Vice President of Data Science and AI Engineering and at Sryv.ai? Sryv.ai.
It's a fun pun. It's I don't know. It's maybe too ephemeral.
This is good. So at Sryv.ai, bringing over 20 years of experience in data science, analytics, and AI. He leads the development of intelligent systems that combines machine learning, automation, large language models, including AI agents that enable real-time, context-aware decision support. Dave is passionate about tuning complex AI research into practical, developer-friendly tools that drive innovation for enterprise and inspire the next generation of AI engineers. Let's welcome Dave.
All right, so the surveys, we want to give these UC students a lesson in looking for bigrams and trigrams, and so make sure everybody says something weird about oatmeal raisin cookies. And when they do like a weird word cloud, first of all, they're gonna go, what the hell did Dave say? Everybody's talking about oatmeal raisin cookies. And then two, like, oh my God, raisin cookies, like bigrams are a thing, like, we'll do some fun there. Fun little Easter eggs. I'm Dave Ramsey. That's me if I were a Muppet. If anybody's curious, I did a couple of things. I've done some smart stuff in the past. I wrote a book over the summer, mostly for spite, and to be able to say, no, I wrote a book on this, and like it sold a few copies, so like, hey, that's kind of cool. It's not a very good book. It's better if you just put it up on the bookshelf behind you, and then your friends and family will think that you're a smart, intellectual person, even though it's probably already true, right? This would be my LinkedIn profile for anybody who, for random reasons, wants to know what I'm up to. I do enjoy going out to lunch, and I'm working in downtown Covington, so there's a lot of good spots to eat. And there's a picture of this goofy book over here. Probably after. Actually, you know what? There's 5 copies left, and I think what we'll do is people who shout out random but slightly appropriate questions at opportune times, you get a copy. And so we'll just make it fun and interactive. So the Muppet thing, 3 years ago, in 2022 or 2023, I gave a talk on like Bayesian analytics and using like structural time series models to do causal inference. And I stuck a bunch of Muppets in there, just for whatever reason. So I spent the last 2 years talking with like the UC Center for Analytics people, talking about like, oh, I hold the record for the most Muppets in a presentation at the Data Science Symposium ever. And so I said something about it on LinkedIn earlier this week, and somebody dared me to go for more. And so you guys are in for a treat. Let's talk about React agents. Everybody know what a React agent is? React pattern agent? I mean, if you're in here, you probably do. If you're in here and you don't know, it's a thing like Cursor or Cloud Code, or it's an agent that basically is a little bit more than just sort of a patterned response to a query. It can make observations, it can use tools, it can kind of do a little bit of chain of thought reasoning and kind of follow its own thing. And so it's got a lot of advantages over like stock ChatGPT, where you can give it a more complex query like, look, I want you to go out and do research on React pattern agents to help assist me in a 50-minute presentation I have to give the University of Cincinnati. And you know what? It can do it and write you a nice little markdown file with a bunch of stuff that you can go source, and it can pull it all from the internet and give you citations and stuff. Whereas, like ChatGPT, stock Claude, stock Grok, or whatever you have, like you ask a simple query and it'll give you kind of like a simple answer without a lot of depth to it. React pattern agents kind of go a little further. Kind of already in here, enjoy the like puzzled-looking cookie monster there, looking longingly for his next cookie.
Is that an oatmeal cookie?
It is definitely oatmeal raisin cookies. So it's React pattern agents actually come from a paper. It's not just a thing I made up. It's something that was published at the International Conference for Learning Representation 2023 by a bunch of folks from Google and Princeton. And so the research before that was focusing on chain of thought agents as a thing, and then tool using agents is another thing. And they said, kind of like the Reese's Peanut Butter Company, like what happens if we put these two things together, right? And so they basically did a paper on the interleaving of like reasoning traces with like external tool actions, right? And so the basic pattern of a React agent is, think, then act, and then I like to say reflect. The actual paper says observation, and that is kind of like the core thing. And then it is a cycle which repeats. And so it will think about what it needs to do, the problem it needs to solve, how to solve that problem, what tools are available, and then it will choose a tool, use the tool, do the action, and then it will kind of reflect and say, did I do the thing? Am I done? Do I need to do more? What do I do next? And then go back to think and kind of rinse and repeat. For those that actually want to go read the paper, here are some links for you. Like, oh wait, it's cool. No takers. All right. So it's there. Grab a photo. This will be up. But it's a good paper to read if you're feeling super nerdy and want some late night reading, and you're like, man, I really, really wish I had more science about React agents. There's the sort of authoritative links. But so basically the loop is a couple of things. So it's thought, right? You get this reasoning trace. It's natural language reasoning. It's basically kind of the way you or I would think about here is a task or a problem I need to achieve. Like what's the capital of, I don't know, Uzbekistan, right? And I don't know what the capital of Uzbekistan is off the top of my head, but I know that I have tools available to me, so like I could go and pull out my phone and search the internet. That would be the action step. And then I could perform the action, view the results, and that's basically the observation step, the feedback where, okay, cool, here are the list of search results that came up. Here is the answer to my question. I am done, right? It is a very natural pattern. And then, quite frankly, I think I talk about this a little bit more later, but there's a ton of steps you can bolt into this, right? So this is the basic core pattern, and the science that's coming out lately with different style patterns, it's really just the addition of additional things into this pattern. And so I have a tendency, after the observation step, before it thinks it's done, to do something like have a QA agent kind of sit back and say, okay, cool. Like, is this actually a good answer, right? Are we satisfied with this? It depends, like if I'm doing research for a client, I'll sort of prompt an agent with sort of like the client's needs and understanding and context about their business. Yeah, you already got a book, you can't get two, but go ahead with the question.
So shouldn't it be observation 1 versus observation 2 to get the delta? Like in your flow, in the loop, before the thought?
Well, it's a loop. So you start with like, there is no observation.
I see.
Right? Observation is null or empty or whatever, and so like you're basically telling the bot, hey, here's the problem we need to solve, and then the bot says, okay, cool, I don't know anything about this, here's how I need to go and approach this problem, here's the metadata I have about the tools available to me.
But is that input your initial observation to start your thought process, technically? I mean, I'm just a little bit of a feedback. You have to go back to the step and make a delta to see what changed from my observation. That's just a comment on that. Yeah.
Well, it kind of does something like that. Because again, it comes down, right? So it does its thinking and says, okay, cool. How do I know the capital of Uzbekistan, right? I've got these tools available, like this phone in my pocket, which has a Google connection. It'll do the action step, so it'll, pull the phone out of my pocket, Google, capital of Uzbekistan, and then the observation step is kind of like, does this resolve the initial question, yes or no? Like, what do we learn from this? Yeah. And then it essentially repeats. And so we'll talk about kind of the steps to break out, but there's a couple of different ways for that. I can jump ahead like 8 slides or something like that. But usually you want to put some kind of like a step count limit or a time-based limit, because otherwise these things have a possibility of going in essentially infinite loops, just like anything else. And that way it doesn't as much, right?
Quick
Yep.
question. So when you're in the action step on that, and we actually are contemplating this on a model that we have productionalized right now. So I assume a legitimate step in the action is, I need more information, right? Okay. Is ask a human, does that count as a legitimate action? When the model doesn't have enough information, it figures out it doesn't have enough information to give a valid answer.
Yeah, so the way you would do that is you create a tool that basically interrupts the script and would just give a prompt that says, ask a human. Or you could actually give it a tool that will, actually
an
queue something
email
up to like a queuing system for a human to answer by sending an email or a text message or whatever. But that's a tool same as any other. As far as the
Just
LLM
another
is concerned.
tool.
Yeah.
Okay.
But usually when I do kind of like more human in the loop type stuff, and you want to have like the ability to kind of like, I don't know, right? We need more information. I'll actually just give it a tool that it interrupts the flow, right? So it breaks out, and then usually the human is me, right? So I'll look at the console and I'm like, oh, all right, like I phrased this kind of badly for this.
Yeah.
Or, I've got a problem with how I've set up the tool metadata or kind of whatever.
Yeah. So like what we want to do is interrupt a business person, a complete non-technician with.
If you want to call Kevin Kelly at 2:30 in the morning, yeah, I'm down. Let's do it.
I'll do that.
All right, sure. We're going to award the first question book right here. Give this man a round of applause.
All right, fantastic. I'm not great with muffins.
You will be. All right, so React in action, right? So again, it's a loop, right? It basically goes until it is complete. And so here is an example, right? Question, what's the population difference between the capitals of France and Germany? Thought, I need to identify the capitals first. So the action is search for the capital of France. The observation then is Paris is the capital of France. And all this is being built into, essentially the context window for the bot, right? There's different ways to store traces. I like JSON lines format, but you can do whatever you want. Then it repeats the cycle. So the next time, now I need Germany's capital, right? So it searches for the capital of Germany, right? Observation then is Berlin is the capital of Germany, right? And then now I need to get the population. So we'll search what's the population of Paris. Cool, Paris has 2.1 million people. I don't know if it's true or not. I just kind of made up some numbers to make this work. Action, search population of Berlin. Observation Berlin is 3.7 million people, right? Kind of repeats the cycle. Thought, now I can calculate the difference. Calculate, the difference between the two. Observation, the difference is 1.6. And then thought, hey, I've got the complete answer. And then it kind of breaks out and uses the final answer tool and says, Berlin has 1.6 million more people than Paris, right? That is an example of a React loop. Honestly, that's the kind of thing ChatGPT could probably one-shot. That's not the kind of thing you'd want to use a React pattern for, but it's a good illustration of it. Also Scooter, right? Come on, who doesn't know Scooter? So why React outperforms alternatives, right? So versus simple prompting, it is. Sorry. Yeah, it's cool. Let's give this guy a round of applause. Yeah, he's a man. I want you to make a scene when you come back, okay? It's got external information it can call, right? So it's your intern that can now Google things instead of just kind of sit longingly at a computer. And so there's simpler versions of bots that can kind of do some of that. But one of the super cool things that it can do is it can kind of verify information for you in real time. If you're using it as a coding assistant, that is invaluable because then it can go back and check what are the contents of other files in the project and kind of think bigger and better than, hey, ChatGPT, I'm working on this script. Here's, this method, update this one, right? It does a little bit better. Studies are showing like a 30% some odd reduction in hallucination versus benchmarks versus full chain of thought stuff. And you can kind of reason out why that is, right? It's pulling in external information. Usually it's using kind of smaller prompting. It's not building up as much I mean, let's face it, like all ChatGPT or LLM output is essentially hallucinations. It's just usually those hallucinations are kind of useful, and occasionally they string together something like weird and wonky. But in this case, like it does a little better at doing like fact-based and kind of grounded research. And so, like I think ChatGPT's deep research is an example of this, where you enable it and it goes through this React pattern a couple of cycles through, and it's not just long chain of thought coming out of the LLM, it's going and bringing in external information into the context chain. And then versus pure action reinforcement learning, right, you have essentially interpretable reasoning traces, right? So you've got all the kind of history of what has happened, and you can actually go and see if it gets the wrong answer, kind of why. And then you can tune and reinforce. And there's actually kind of whole frameworks that are coming out about modeling and monitoring remote bot telemetry. And like I'm not talking about any of those today, but you can Google it and they're there. In fact, go and use deep research on Google or Perplexity or any of these that are React pattern agents and say, hey, go research this and find one for me. But essentially, you've got telemetry now that you can kind of figure out what your bot's doing behind the scenes and course correct if necessary. Boy, I feel like I'm all over the place here. In my head, this was a much cleaner presentation, but we've talked a bit about how they work. Reasoning loop mechanics. There's Rosa with a nice hula hoop, for those of you expanding your Muppet lore. Do we all know Muppets, by the way? Like that's, I feel like I'm dating myself. That was a thing, and that's, yeah.
Can I ask a bad question? I don't want a book. I don't need a book. I'd love that.
But no, you can't. Like, you have to take a book.
All right.
It's cool. You don't get a book. Go on, Matt.
So, is like Claude Sonnet 4.5, is that an example of a React?
Claude Sonnet 4.5 is not an example of a bot.
Okay,
But,
but it thinks, so what's the difference?
well, so that's chain of thought reasoning, and it's not going much deeper than that. And so what it'll do is behind the scenes, and it's doing this with a series of tokens, it's just sort of injecting into the context to differentiate thought versus response. In the same way it differentiates in the context stream, like a user message versus an agent message. But so it's just basically kind of reasoning out a longer sort of set of like pre-context for chain of thought reasoning, like behind the scenes, and then it uses that to kind of generate its final answer. And it is all coming out of the knowledge of the bot. Sometimes it might use a tool, right? So the lines are a little bit blurry now because it's been a couple of years. But Claude Code using Claude 4.5 Sonnet is a React pattern agent at its core. Like they've added some other stuff to it, so it's not like a pure 2023 React pattern agent, but it's a good example of like how it does that. So we use Claude Sonnet 4.5 as the LLM that powers it, and it will follow essentially kind of that React pattern through and through in order to actually generate the answers for you, or the output. Or a lot of times when you're using a React agent, what you actually want isn't technically an answer, you want it to do a thing for you. Go and send an email to this, or go and pull all the social media responses for the last 24 hours of this, or something. But go out and do an action against the data from the external world and then kind of bring it back to me in a form that I can make use of. And so that's sort of a better example.
Okay.
Make sense?
Yes.
Everybody confused now? Oh, yeah, this guy right here. All right. So reasoning loop mechanics, we've kind of talked about this over the last few slides, but again, it's your prompt construction, right? And a good prompt for these is, and I'm sorry for the small text, I thought this would work better. But you have a system prompt, the same as you do anything else. Hey, you're a helpful assistant, you're gonna go out and do this, you're gonna go out and do this. Here's your role, here are the tools available to you to perform what I want you to do. Here is the format with which I want you to reply to me. And then, technically, you could do these as zero shot, and they sometimes work, but React pattern agents need at least single shot or few shot to kind of understand the pattern you want them to follow, because otherwise they kind of just don't do it, right? And you could also game that in a couple other ways by, I don't know, you could have like separate agents performing different steps in the React pattern. each with a different prompt, and like that'll kind of get the same job done. But you're going to get better following of that React pattern if you actually prompt it with like 2 to 3 examples of the pattern you want it to follow, right? So give it a think, give it an act, give it an observation type step, and then repeat that 2 or 3 times in your prompt, and you're pretty much good to go. And then current conversation context. So if there's anything else you wanted to know, or like you've had it previously interacting with some of these things, or you just wanted to like continue on because again, these bots kind of produce a continuous stream of context. And so I personally like to write those to little like JSON lines files, JSON-L files, and then you say, here is your current context, and it appends every time it goes through a loop, and then kind of feeds it back on itself each time it's called in the next stage of the loop. But honestly, like there's a ton of different ways you can go, right? But so those are the kind of like the big components of the prompt construction. You've got the LLM generation, which is just you're calling the APIs there, right? So you're calling OpenAI, you're calling Grok, you're calling Claude from the API, and so you've got your standard message construction type stuff there. And so here's the user message, here's the agent message, here's the agent system prompt message, and the appropriate sort of dictionary formats there. Depending on language, Python versus R, it's pretty similar. And then action parsing, so you've got to be able to extract the tool name and parameters, and I think I talk about this a little bit more, but a lot of higher level tools for doing this, if you're not doing it by scratch, will actually give you a tool decorator. And so in Python, you could say @tool, and then here's your method that you're going to define, and it will just register that as a tool for you. If you're doing it by scratch, you've actually got to do it by scratch, right? So it's a little bit more involved. But it's the same stuff. If you've ever registered, yeah, please save me, thank you.
Question, so
Yeah.
is it better to have one LLM with many tools or one or more LLMs with 1 or 2 tools?
It depends, right? So if the tool usage is incredibly specific and you have fine-tuned an LLM instance to be able to use that tool really well, like, yeah, you might actually do that. In fact, you might actually make your tool call method for that tool actually reach out to an instance of that other LLM on your behalf, right? And like the lines get kind of blurry because tool calls are actually just LLM calls kind of wrapped up in some stuff that comes back to your machine to then run the Python code or whatever. But
I mean, if you have like one LLM call with many tools,
Yeah.
shouldn't you ideally make the cost lower because you are making one LLM call?
it could.
Because the tools are basically your methods, local methods.
I think it's a thing that's fit for purpose, right? So like I don't know that I could just say one way or the other. Like I mean, I'll make up an answer. It's better to have one LLM handle it. No, I don't know if that's true or not. I think it's like all things LLM, it's evidence-based development, and so like build, but like as you're building, test and make sure you're getting kind of what you want, like 90% of the time or 95% of the time, because like it's. And I mean, one of the things I love about LLMs and one of the things I hate about LLMs is like when it's working, like, oh man, like, oh, this is amazing. And then when it doesn't, yeah, like why are you doing this? Like I've never wanted to like furiously scream at like my computer more than, like why aren't you doing this? And it's always random stuff like, oh, like this model, we've got it quantized too far down and so it's given a lobotomy and I actually need more model. Or, like the frontier model we're using with API tokens today is having a conniption and they're having some API service issues or something. It's just weird random stuff. And so it's a long way to say, I have no idea. That's what you came here for, right? Congratulations, you stumped me, you get a book. Take the book, you have to have the book. It's the law. Isn't that right? Back me up, you see.
Oh, yeah.
Yeah, see? Thank you. All right, and then so like step 5 there is you just repeat, right? That's a fun one. So for the future historians here, this is a clay figurine of a Muppet. I don't know if this increases my Muppet count or not. It's when they're defending my record in 5 years, when somebody's like, oh, I did more Muppets than Dave, like they're going to be pulling out reference manuals and stuff, like is this actually a Muppet going to committees? So termination conditions. So it basically, this is a repeat forever loop, right? Computer scientists in here? We let loops continue forever? No. And so you gotta basically tell it when to stop. And so, there's a couple of ways to do that. The first is, final answer detection, right? So the bot can determine that, okay, cool, on observation, I feel like this is my final answer, and so I'm gonna stop, right? It can reach, and this is, I usually use kind of a combination of these, like a maximum number of iterations. And so, depends on what you're doing. Honestly, if I'm doing like deep research and I've got it doing a bunch of web searches, I'll usually stop it at like 3. At that point, it's usually got enough information. And if it wants to go on beyond that, it's just because I haven't prompted the bot well enough to say, like, recognize when you have enough to stop. And I can shortcut that instead of arguing with the bot ad nauseum to try to get that prompt right. I can just say, cool, like in the code, there's a maximum number of iterations you can run of like 3 or 5 or 10 or 15 or whatever is kind of fit for purpose, right? Similar to that, you can actually do timeout constraints, right? So you can limit to a fixed number of time, and so you essentially start a timer, run your loop, and then at the end you say, you're done. We're gonna take what we got. Or we're going to just go to load the trace file and we'll have another LLM kind of summarize the best possible answer out of that. And then maybe start another iteration or not. But there's that. And you can also kind of do it with token limits, right? So you can say, hey, like we're going to give you a total of 200,000 tokens to use. And at the end of it, you either give me an answer or you stop, right? And so don't go on beyond that. You use something like tick token or whatever to count them pretty easy. Or you can actually build your own tokenization thing and like, hey, more power to it, right? Especially with things like, what do they call them now? Open weight models, like you get on Hugging Face there. They all kind of have their own tokenizer and everything tokenizes ever so slightly differently. So if you're trying to count tokens based off how OpenAI defines it, like it gets kind of squirrely kind of fast. My personal preference is just iteration counting. It's like the simplest to implement. Context window management, and again, this is, actually Cloud Code kind of does this real nice. And so like when the token window starts to approach what it can do with 200,000 tokens, it'll actually kind of step you out and say, okay, cool, like you either need to compact this history or I'm gonna do it for you. But essentially, every iteration of these bots adds tokens to your context, right? And different models have different context lengths. And so if you're doing something like deep research and you are reading in long PDF documents from a thing because you want to read and summarize and find all this information that you found on the internet, you can start running into things. Honestly, the newer models are pretty generous with the number of tokens you can use. And so, if we were giving this talk a year ago, we'd be talking about like 128,000 tokens or whatever, which is already pretty good. It's better than like 3.5, which was, what was it, 60,000 tokens or something? I mean, it was just a year ago. I should know this, right? I don't anymore. But like ChatGPT 4 was 128K tokens. ChatGPT 5 is, 400,000 or so. Claude generally is about 200,000 tokens. And so generally it's not enough for like a 20-page document. And any longer than that, you got to start thinking about like compaction strategies. Most of your use cases, it's not going to matter. Use a frontier model and you're good to go. Use something from Hugging Face though, and it might be a little more serious. And so there's a couple of ways to do it, right? So the first is like, what they call sliding window. And this is like with time series predictions where you just kind of slide the window through and use that to kind of train a model and understand the goodness of fit. But you'll only keep the most recent 20 steps or something like something that you have benchmarked and tested and know is going to fit within that context window most of the time with like a good safety margin, especially if it's going to be a production system. Summarization, which is you basically say, okay, cool, Claude or ChatGPT, here is my total context for this conversation. I need to compact it, summarize it for me, and then you start with, instead of like a 400,000 token document of a conversation with the summary of like 10,000 tokens or something that represents kind of like the broader thinking in the bigger document. selective retention, you can get kind of smarter about this. Token budgeting, you can reserve space for different stuff. When I've done it, I've generally done sliding window or summarization, right? Or just honestly kind of limiting the number of responses back from the previous LLM calls so that I've got a huge safety margin and I don't even have to worry about it, right? Hey, there's a back scratch right there, a couple of muppets there, building from scratch. Come on, it's a pun, it's great. All right, I appreciate the pity. No, you don't get a book. Okay, you can do it. What's up?
Just since you're moving to a new topic, I wanted to touch back on the LLM question.
Yeah.
Obviously it's not about the number, but the right LLMs that you use. When you are in that step and you used your tool call.
Yeah.
From a do you go back and say, you know what, like I wrote this 6 months ago and there's like other tools now or something different I can use? Like how often do you go back and think about the tool that you is called?
Well, so the tools that I'm calling are usually like Python methods, right? And so it is a little function on my computer that when the bot says, hey, I want to do this thing, like it's actually my computer that's executing the code. And so usually for whatever purpose, I have added the number of tools I feel is appropriate to do the
So you're
thing.
talking about Python.
Well, yeah, like Python methods. Now, like there are other sort of like off-the-shelf tools now that exist as part of this. And so if you use OpenAI's, it's not the conversations framework, it's the responses framework. Now you're able to have access to a couple of their tools like image generation and direct search. And so those operate a little bit differently. You can still kind of register them, but what I'm talking about here with these React pattern agents is tool calling would be something like you have written a tool that will write output to a file, or you have written a tool that will allow it to read a file from a directory, or you have written a tool that will allow it to execute a bash script, or you've written a tool that will allow it to do whatever. And so what happens then is basically the LLM says, I want to use this tool, and then that comes back as a structured set of metadata to your computer, and it will execute that tool. Hey, come on in. In fact, why don't you sit right up front?
Yeah.
No, I'm kidding. You can sit where you want.
See, I know
Thank you
him.
for
He's-
that clarification, that
Yeah,
helps.
yeah,
I
but
was-
yeah, I mean, some of these like there's also like MCPs now, which are a thing, and they're kind of like tools, and they're kind of not like tools, and so like the lines are more blurry than they were a couple of years ago. But if what I'm talking about here specifically is tools written in Python or R or C
Thank you.
or whatever that live locally to the code you're running, like the bigger script that's calling the React agent, which actually lives on a physical machine somewhere, right?
Thank you.
Everybody also clear as mud?
Since you just came, can you repeat everything?
I'm on it. Let's go back to slide 1. No, it's cool. You can see me after class. I'll get it going. So core architecture, man, we've talked about this a couple of times, but so you've got the LLM interface, right? So that's the brain behind the scenes, right? And you can use pretty much any LLM for this. And so like benchmarking, you'll see like the performance of LLMs for different like tool calls and that kind of stuff. Some are better than others at recognizing when we need to use tools. Claude, I think, actually performs better. Hey, welcome back.
Thank you.
Yeah. Kept your seat warm for you.
Thank you.
But like basically you can roll your own, right? It's just handled by API, the same as anything else. And you could roll Claude, you could roll OpenAI, any flavor of theirs. You can actually use transformers from Hugging Face and PyTorch and host your own. You can use a flavor of Llama. It really just depends on like what you've got the actual computing power for. Time and latency constraints, security constraints, and so like, all the decisions into which LLM to use like still actually apply. And then you've got the tool and action registry. So that's the catalog of available tools with descriptions. And I think I spelled this out explicitly later in the deck, but your tool descriptions are also effectively LLM prompts. And so be like super descriptive about them and how to use them, because it is a great way to inject that extra knowledge into your bot so that it does what you want the first time. And if you find that it should be using a tool and it's not using a tool, it has everything to do with your tool description of the registry, right? Observation handler, right? So it's able to go and execute tools and format the results and kind of do all that stuff. Loop controller, that's just Python that is basically running your thing forever until you meet one of your stop conditions. And then state and memory management, and so that's for a lot of the stuff I do, it's a JSON file, it could be a text file, it could be something in memory, it just kind of depends on how you want to set it up. But those are the 5 architecture components that you need to basically build one of these from scratch. So I did a super minimal Python implementation of this for you, and like it ended up being 8 pages. And so then I was like, okay, cool, I'm gonna desperately cut stuff out until it's down to like 2, and I settled on 3, and so I don't know how good this is gonna translate, but we're gonna go for it anyway, right? We'll give it the college try. And so keep in mind, there are 3 pages of stuff, right? And probably could have cleaned up those import statements and saved 2 lines there, but I didn't feel like that was that important. And so you basically define a class, or do it however you want, right? This is just how I would do it. And what do I know? I'm just some guy up here kind of with a microphone that I don't even know how to use because they didn't show me. So you've got this React agent class, right? It's got all the kind of stuff, but you've got your client defined, which is the LLM you're choosing to go with. And so you can see I'm literally piping in directly the OpenAI method into the client object here. The model is a specification of the model you want to call, in this case GPT-4o, it could have been GPT-5, it could be a very specific, OpenAI likes to name theirs with like a date attached, and it's a good idea to use those because quite frankly they change stuff all the time and you can go from great to done just like that. Or you know what, like maybe you like to live dangerously, go for it. I'm done, hey buddy. You want to come up and finish for me? No? Are you good? Okay. Right, and then self.tools, right? And that is your tool registry that goes there. It's really, really, really long because again, that is basically prompting. And I took that out completely. Go search, I think I've got a slide in here later kind of showing how to do it. But man, like search, it's basically, there are some tools for kind of wrapping up how to do it for different LLMs. They all need slightly different metadata definitions for tools. But that's the gist of it. So that would go there. This calculator method here, this is an example of a tool. It is about the most minimal thing, which is like, cool, I'm going to give it an expression like 2 + 2, and it will then execute the thing for me. And don't allow eval stuff in production code. Like, no, that's bad, right? Because security risks and stuff. But for this minimal example, like it will work. And then more tools would be defined here. You'd probably have, depending on the bot, 20 or 30 of these things. And again, tools, you got to think really, really low level. It can read a file, it can open a file, it can save a file, it can write to a file and append to a file. And you can give them different rules. You can't append to a file without having first read the file or something like that, right? And then you get a method to basically execute the tool. And so this belongs to the React agent class, and it's just a method to execute the tool. And it, you'd have a set of expressions to kind of figure out, based off how it responds to you saying, I want to use this tool, what do you then do, right? And so that is kind of the basic preamble stuff. I'm going to pause there. Everybody get this down in your notes, man. Like everybody copy everyone. Good? Okay. All right. And then I've got this method I've just called run, which is a good way to do it. But it essentially is that loop controller we talked about, right? So it's got code up at the top there to basically like append the correct message format for the bot you're using. It's got something to say, you're only allowed so many iterations, right? And it will sort of limit that. It's doing its message appending, it's checking, okay, cool, does the agent want to use tools based off its response back to me? If not, then it basically outputs the response in the appropriate format for the trace file, right? It's a lot, it's cool. There's easier ways to do this than like 3 slides. We'll take all this down to like 3 lines of code. And then the last one is just cool. We're going to run the code. Here's a test question, and essentially kind of given a prompt to go solve. Again, super minimal example, and a better prompt you'd be giving it some like few shot examples of how to do this, right? Woo! All right, we did it, guys. Congrats. I met the bare minimum qualifications for, you know, what I put on the thing. All right, so tool registry design. I think I alluded to this. I'm glad I put the thing in. Tool descriptions are your prompts, basically, for a lot of this. So it's a good way to inject information into the model when it needs it. But you have, and again, the tool registry, the metadata requirements vary a little bit by model, but they're all kind of basically very similar to the OpenAI standards. And OpenAI, if you actually search for it, has a tool that will build it for you if you give it the function, and then you can just kind of expand on it. But the gist is you need a name, right? You know, the name can be searched, the description, which is your prompt, don't forget. And so make it long and detailed. The parameters that the function takes in the method, and some metadata about them, what it returns, and sort of an example of the thing. These are sort of what's required as metadata to then pass to OpenAI as a possible tool use. You can actually do this like super duper old school before they actually had API methods for it and try to parse it out with regex, and man, good luck. So, yeah, no, I think good luck kind of covers that one. So, tools and frameworks. How am I doing on time, by the way, timekeepers?
10 minutes.
10 minutes, what? No.
7 minutes actually.
Yeah.
All right, cool.
So before you jump
Yeah,
into the next section.
Congratulations.
Oh,
No, you
oh,
get it. It's the law, we covered this.
Oh my God, all right, thank you. So before you jump to the next section, I just want to clarify.
Yeah.
I'm new to this, so maybe this question doesn't, the numbers should make quite sense. So it seems like from the code you're showing, it's quite mechanical, right? Can you speak about the training process of this React system? Are there any training going on for the LLM, or you just piece them together and that's
Well, so I'm going to give two answers. And the first is that no, you just take a pre-trained model, and it will generally be able to kind of reason this out. And so the more capable the model, the more of on a spectrum from like, I don't know, something like Word2Vec to, you know, like ChatGPT 5, which is frontier model, and the full, you know. Like the more towards the frontier and more compute power, the more capable it is of figuring it out on its own. Now, a lot of these have benchmarks for things like tool usage, and that's a good guide for like, can I use this model or not behind the scenes. Now, that said, you can actually take, if it's well, even if it's a frontier model, you can do like fine tuning with OpenAI models and kind of like build your own flavor where you give it some good examples of how you want it to perform, and then sort of you know, run it through and it will fine tune, and as long as you haven't given it too much information, like it usually gets better, unless like what they call catastrophic forgetting happens, in which case like it pops. And there's like no rhyme or reason for it just yet. I'm sure somebody's got a paper somewhere and I can't keep up with all the science anymore. But essentially, yeah. But generally for this, like my implementations, I've always just used a frontier model. I pay by token, and they were generally pretty capable of doing it. So you don't need a custom model or a fine-tuned model. You just kind of give them the appropriate prompting and do, right? So, which is a cool thing about LLMs, right? Because you know, like you can. I got the official 5 minutes. All right, guys. Let me scan through, figure out if we got something here that I would call important. Yeah, so framework landscape. Here are some good ways to actually do this that are not by scratch. LangGraph is really the only one I'd actually recommend. Good luck with their documentation. It's one of those there be dragons where they have all the documentation forever, but like everything has changed and good luck. But you can essentially, here's a full React pattern agent using, you know, Claude Sonnet, one of the models. And so it is done in 5 lines. And I mean, you could expand on it a little bit more. You can give it more tools or kind of whatever, but it is kind of a more useful syntax. And I believe they use the tool decorator syntax in Python. So a decorator is something where, you know, if you were to take a function and then have another function go register it somewhere, that @ symbol says, hey, you're going to go register this as a tool with something to receive it.